Hello, this is the first video on our channel, and hence I would like to take a couple of minutes to discuss what is the goal of this channel, why we are starting it, and everything. So, what we observed in the current content that is available on YouTube is that the content describes all the technical topics in great detail, and which is amazing for understanding or studying it. But when it comes to interview or exam preparation, it is very difficult task to just go through everything that you need in those long term form videos. So what we plan to do is cover every essential topic that is necessary in form of software engineering primarily, and then we may move out to some other topics as well, and just cover them for you in great pace and so rapidly, yet covering every point that is necessary for your exam or interview, and help you prepare just a day before exam, as we always do in our engineering curriculum. Thank you. Now let's move to the today's video. In this video, we are going to revise object-oriented programming. This video can be helpful for your exam or interview preparation. The topics that we are going to discuss today are classes, objects, and the four pillars of object-oriented programming, which are abstraction, polymorphism, encapsulation, and inheritance. Moving on to what is a class. Classes are the templates for creating objects that define the properties in form of attributes and behaviors in form of methods that objects of the class will have. They act as a blueprint from which objects can be created. Let's consider an example of car category LMV, which stands for light motor vehicle. Now, the category LMV only provides a template of how a car should be built, but we know that every car that is available in your market follows these protocols or follows these guidelines or frameworks set out by the class LMV. Hence, LMV could be considered as a class or template for cars. Then moving on to what is an object. So object is an instance of a class. Now continuing with the same example of LMV that we were discussing earlier, any car that you find in the market ranging from the basic entry level Alto to a Rolls-Royce Phantom is going to be registered under the category of LMV, and hence it is going to be an instance of class LMV. Now we know that there could be multiple properties which are common to every car in the market, like width, height, engine capacity. Then there could be some behavioral characteristics like transmission. Now it may be implemented as manual or automatic in form of CVT, DCT, IMT, etc. But every car is going to have it. So it is sort of an object of the category LMV. Moving on to our four pillars of object-oriented programming: abstraction, polymorphism, encapsulation, and inheritance. Let's discuss our first pillar of object-oriented programming. Primary goal of abstraction is to handle complexity by hiding unnecessary details from the user that enables the user to implement more complex logic on top of the provided abstraction without understanding or even thinking about all the hidden complexity. Now let's take a look at the car example from a different perspective. When we say that we buy a Nexon, we are not actually buying a Nexon, but we are buying some variant of Nexon. Nexon Petrol XZ Plus, which could be an example of a petrol manual variant of Nexon. Then there is a Nexon Diesel XZA Plus, which could be a diesel automatic variant of Nexon or any other EV variant as well. But still, we commonly refer to it as a Nexon, right? Here is the abstraction that goes under the hood. Now, when we consider Nexon as an abstract class, we have defined just a basic structure of Nexon as a car, but not some of the core components like engine, then many of the features that come as configurable in form of variants. Now, when we come to a second level, that is Nexon Petrol, then we say that the engine of the car is defined, but yet many of the components which are configurable, like there should be a sunroof or not, the wheel should be an alloy wheels or some simply wheel caps, etc. Many of the configurable components are yet to be defined, and hence still it is an abstract class. Now, when we define even the variant, then it forms Nexon Petrol XZ Plus. Then this is a variant that is a complete with all its components, and an instance of this variant can be created, and hence this is a complete class. Now let's take the full picture or take a look at this full picture. where we see LMV as a category as an interface which is totally abstract. Then we come to second level where we define individual cars basic structure which as an abstract class, and then finally coming down the line we finally define every component of the car, and then it forms a complete class whose object can be initialized. Again, having a look at the definition of interface, an interface is a description of the actions that an object can do. It describes a set of method signatures, the implementation of which may be provided by multiple classes that are otherwise not necessarily related to each other. This again is an important point because you know that LMV can be, if we are considering the example of LMV as an interface, then you know that every car is going to implement the same interface. That is, basic structure of every car is going to be same, but still the design language is going to be different, and again the brand strategy, etc., everything is going to be different, but just the interface that we are going to provide is going to be same. Hence, although the classes may not be related to each other, but they still may be implementing a similar interface. Moving on to the second pillar of object oriented programming, we are considering polymorphism. The classic definition for polymorphism that you must have heard while polymorphism was taught to you is poly means many and morph means forms. Hence, polymorphism means multiple forms. Polymorphism refers to the ability of object to take on different forms or behave in different ways depending on the context in which they are used. Now, there are two types of polymorphism. One is compile time polymorphism, and there is a runtime polymorphism. Let's consider compile time polymorphism first. Imagine if we define two methods or functions with the same name such that only their type of parameters or number of parameters, or maybe both, differ. In this case, we call it as function overloading. Now, in this scenario, our program will have to decide that which method should be called, right? Now, this decision is taken at the time of compilation itself because anyway it is going to know the actual parameters at the time of function call. So at the time of function call itself, it can compare the actual parameters and formal parameters of each of the functions defined, and hence we get to know which method is going to be called. This is going to be called as compile time polymorphism. The next is going to be runtime polymorphism. Imagine that a class parent inherits another class named child, and both classes contain a same method with same parameters named walking. In such a case, the decision of which method is to be executed is going to be taken at a time of runtime based on the scope. So if child calls it, then the nearest scope is going to be child class itself, right? Because child class itself has a method named walking. So it is going to execute a child class walking method. If it doesn't find a method in the child class, then it is going to refer to parent class. Finally, coming to encapsulation. Encapsulation is sort of a theoretical concept where we consider the organization of a program in form of packages, etc., and use of access modifiers through which we can modify or restrict the usage of particular class or particular methods from class to multiple classes from maybe the same package or maybe from the different package. Encapsulation refers to the bundling of data with the mechanisms or methods that operate on the data. The final pillar of object oriented programming is inheritance. Inheritance is a mechanism that allows a class to inherit properties and behaviors from another class. It is a fundamental concept in object oriented programming that promotes code reuse and establishes relationships between classes. Primary types of inheritance are three: single inheritance, multiple inheritance, and multi level inheritance. Let's have a look at them. Types of inheritance can be a single inheritance, that is, there is a simple base class and then there is a derived class. There could be multiple inheritance, but this requires the use of interfaces in case of Java because Java cannot extend two classes at the same time, and the reason is a diamond problem, which maybe we will discuss in some of our further videos. But in Java, it is still possible to implement two classes by defining it as an interface. Then finally, we have multi level inheritance, where a grandparent can be extended by a parent, and then further its child can extend his own parent. So this is sort of hierarchy or generational hierarchy is formed due to multi-level inheritance. So these were the three types of inheritance, and here we conclude our video. We have covered so far classes, objects, and the four pillars of object-oriented programming, which are abstraction, polymorphism, encapsulation, and inheritance. I hope this video will turn out to be helpful for your exam or your interview preparation. Thank you, and best of luck for whatever you're aiming for.